Unless a pod's restart policy is set to never, it will restart any of its containers that have crashed. However, it's not uncommon for programs to become unresponsive due to a hidden bug and yet never crash. Unfortunately, the pod would never notice that there's a problem. Consequently, it would never restart the zombie container. What we need is a way to determine if a container is healthy or not. When a container is determined to be unhealthy, it can be automatically killed and replaced with a clone. This is where container probes come in.
A probe is a health check which is performed on a container. Probes can be used to determine whether a container is alive and healthy, or just a useless zombie. Probes can also be used to determine if a container is ready to receive traffic. Here's how probes work. The kubelet process runs a probe by executing a probe handler. Probe handlers contain the logic behind a container health check. When you create a pod config file, you can specify a probe handler on each of the pod's containers. There are three types of probe handlers. The first type is the exec action handler. It executes a Linux command as the container health check. If the command exits with the status of 0, then the health check is considered to be a success. If the command exits with a non-zero status, then the health check is a failure. The second type of probe handler is the HTTP GET action handler. It makes an HTTP GET request to the container at the specified port and path. If the response code is in the 200s or 300s, the check is successful. If the response code is in the 100s, 400s, or 500s, the check is considered to be a failure. The third type of probe handler is the TCP socket action handler. All it does is try and establish a TCP socket connection on the port specified in the handler config section. If it's able to open the port, then the check is successful. Otherwise, the check's a failure. This is the config file for a pod, which has an exec action probe handler. The probe is used to determine if the example container is alive or not. The exec liveness example container creates a file called healthy every second or so to indicate that it's doing okay. This is the probe handler. It attempts to remove the healthy file. When the file is successfully removed, the probe succeeds, but when no healthy file exists, the rm command returns a non-zero status code to indicate failure. By default, the handler must fail 3 times in a row before the probe itself is considered to be a failure. Only then will the container be restarted. The initial delay seconds field sets the number of seconds before the probe will start doing its thing. The period seconds field controls how often the probe will be executed. Here's the script that the exec liveness example image runs. For 10 seconds, it'll use the touch command to create or update the healthy file. During that time, the liveness probe will repeatedly delete the file. After the 10 seconds are up, the script goes to sleep. This simulates a program which enters an unrecoverable state, but is not actually dead. It's up to the liveness probe to detect and fix this problem. We're done with the tour, so let's create the pod. Take a look at the output of the describe command. Particularly, check out the events log. Everything appears to be okay, and the restart count is still 0. After letting a little bit of time go by, let's run the describe command again. Notice that the event log now shows a warning. The liveness probe failed because it couldn't remove a non-existent healthy file. When we get the pods, notice that the restarts counter was incremented from 0 to 1. This is the result of the failed liveness probe and just what we were hoping would happen.